Welcome to another tutorial by Longhorn Physics. For a couple of these videos here, we'll take chapters out of a book called My First Book of Physics of Motion. Here's a tutorial on graphing and motion graphs. So let's say you drive down the road at 70 miles per hour without changing speed, and you're moving at constant speed, right? Constant velocity. Our equation for that would be your average speed would be distance divided by time. But understanding and creating a graph of motion is also part of physics. Here are the graphs of constant speed. So we have constant, which means not changing or uniform. So when you have a distance versus time for constant speed, you get a straight line with some kind of slope. We'll learn more what that means in a minute. When you have a constant speed, your v, which is your velocity or speed graph, would be a flat line. So no matter what speed you're going, it would be a flat line because it would stay constant over time. And then if you're at constant speed, then in physics you're not considered to be accelerating. So you can see here at the zero line, at the 0 point, we'd have a flat line that we draw at 0. Okay, so what we need to learn is that the graphs actually do mean something. So here's the graph of distance traveled or position versus time. And what you can do with that graph is you can use to find the average speed in the object. So what do you have to know? When you look at the graph, you have to know that the slope of your line is your average speed. So knowing that, here's a little practice problem. It says use the graph to find the average speed at 5 seconds. So here's our distance versus time. We got a straight line there. So our slope would be change in y over change in x, just like in your math class, which in this case would be our distance divided by our change in our time. So as you can see here, we got four units in the x direction, and our change in x would be 5. So when you see a motion graph and you're asked to find the average speed, you simply take the slope of the line. Also, the steepness of the slope also means something. So let's say we have two objects moving 1 and 2 represented here by the graph. Which one's moving faster? Well, here's the rule. The steeper the slope, the faster the object. So that means that in this case, object 1 is moving faster than object 2 because it has the steeper slope. Okay, so the last thing we'll talk about is when you have a speed graph, and there's a story in the graph there also. What does the area underneath the curve represent? Well, the area, which is a rectangular area, represents the distance traveled by the object. So to calculate that, you simply have to remember your geometry and what is the area of a rectangle, which is just your base times your height. So in this case, we'd have our velocity and our time. So the distance traveled is just the base of this rectangle times the height. Now, what does the line drawn at 0 mean in this graph for constant speed? So again, it means that the velocity is constant, not changing or uniform, so there is no acceleration. So here would be an actual problem going over what we just talked about with the speed graph. So if I have a speed graph here and I see a flat line, then I know it's moving at constant speed. And if you want to know the distance traveled, it's simply the area of this rectangle here. So you just simply multiply 10 times the height, which is 3. So what is the distance traveled by this in the graph above? It would be 3 times 10, or 10 times 3, which gives you 30. And since it's distance, it would be meters. So 30 meters would be the distance traveled. So this tutorial is part of my book called My First Physics Book of Motion. It's a 153-page book that's designed for students new to physics from high school to collegiate level. It makes sure that you learn the fundamentals, the terminology units, has problem solving and problem solving skills. So you show 2 different methods there for solving problems. The study guide takes a hands-on approach, has many interactive tables, worksheets, and mini quizzes. And then, of course, you see how this is referenced to the book. It's available at starstudyguide.com or straight at Amazon.com. I guess typing these keywords will help you find it. But if you go to starstudy.com, spelled with two A's there, you can link to Amazon. If you think you want to see more about the book,